In this video, we're going to graph a polynomial equation that is written in Vertex form. So written on the screen, we have what's called a polynomial equation. You'll notice this looks a little bit different than our quadratic functions because our quadratic functions only had 2 x values, and this one has 3. Now, this looks a little bit tricky, but believe it or not, we have all of the knowledge that we need to create an accurate sketch of this graph. So if you're thinking that this looks a lot like intercept form, that's because it is. This is intercept form of a polynomial. So what's nice about math is a lot of those same patterns that we just saw with quadratics apply to other types of graphs. Polynomial equations are included in this. So here we can see we have intercept form. So these work just like P and Q. What we're finding here is instead of having 2 x-intercepts this time, we actually have 3. So we actually have an x-intercept at, here in this case, -3, 0. Remember, it's opposite of P and Q. So -3, 0, -1, 0, and a +3, 0. So this intercept form of a polynomial equation is telling us we have intercepts on the x-axis at -3, -1, and 3. So let's go plot these. So I have -1, -2, -3, and then 1, 2, 3. So if we plot these, so we have an intercept at x equals -3, x equals -1, and x equals 3. So that's the first thing we're going to do. Then from here, what we can actually do is we have what are called local minimum values and local maximum values between all of our x-intercepts. So it's kind of, if we think about a quadratic and its vertex point, we're essentially going to have a quote-unquote vertex point between each set of x-intercepts. So what we're going to do here is we're going to estimate where these local minimum and maximum points are by finding the middle ground between our different x-intercepts. So we're going to look at, okay, what point is in the middle of -3, -1? What's in the middle of -1 and 3? And basically, it's like finding a vertex between each pair. So it's just going to be an estimate of where this local min or local maximum point could be. So if we start with these first 2 points here of x is -3 and x is -1 for our x-intercepts, we find the average. So we have -3 plus -1 divided by 2. So that's -4/2, which is -2. So we know at x equals -2, approximately, there's going to be some sort of local minimum or maximum point that we reach. So from here, we're just going to plug that value into our equation and find out what the corresponding y value would be. So we're going to take -2 plus 3, -2 plus 1, and -2 minus 3, which becomes +1, -1, and that becomes -5. So if we multiply +1 and -1, well, that becomes -1. Then we're going to multiply that by -5, and we get 5. So what we find here, and I'm just going to estimate where this point's approximately going to go, is that when x is -2, y is 5. And that's just an estimate of where a local maximum point is, because you can now see, if we start to sketch this out, this graph is going to have to come up, reach about this point, and then come back down. And then it means it's going to be continuing this way as well, because it's going to come up, hit that maximum point, and come back down. So we have an idea of where this is going to go. So now from here, let's find the other point. So we have -1 and 3, and we need to find the average between those. So we have -1 plus 3, which is a +2. Then we need to divide that by 2, which becomes 1. So we know that our other local max or min, which is between that other pair, so these two, other pair of x-intercepts, is occurring at x equals 1. So we've got some sort of minimum or maximum point. It'll kind of look like a vertex occurring right there at x equals 1. So now if we substitute x equals 1 into our equation, we have y equals 1 plus 3, 1 plus 1, and 1 minus 3. So we end up with 4, 2, and negative 2. Well, if we multiply the first two, that's 8 times negative 2. That's negative 16. So I can estimate that down here, when x is 1, y is negative 16. So now I can continue my sketch. I know that it's going to be coming through and hit down there at 1, negative 16, and then it's going to curve, come back up, and go all the way through the graph. So I can see here that it kind of looks like it has two quadratics in there kind of smushed together, but here we have our polynomial graph. It's in our intercept form, so we have our x-intercepts in these three locations of negative 3, negative 1, and 3. And then we can see that we have a local max, which means its maximum point within its space locally, because we hit a top point and we curve back down at negative 2, 5. And then we have an approximate local min at 1, negative 16, as it comes down and then starts curving back up. So these are approximate local maxes and local mins that we can use to estimate exactly where this graph is approximately going to fall. So let's try one more example here. So we can see again that this is written in intercept form. So we can start by finding our x-intercept points of this particular polynomial equation. So we start off and we label what our x-intercept points are going to be. So here we have an x-intercept at opposite, so 5, 0. Here we have one at negative 1, 0. And here we have one at 1, 0. So here we have our three x-intercepts, and let's estimate and plot them on our little coordinate plane here. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So if I'm going to take a different color here so we can see them. We have an x-intercept point at 5, 0. So there's going to be one there, and I'm going to label it. I then have one at negative 1, 0. And then I have one at 1, 0. So I have all three of those x-intercept points labeled. Now, from here, I know that there is a key point between every pair of x-intercepts. So I'm going to start with these first two right here, negative 1, 0 and 1, 0. I'm going to start by finding that key kind of axis of symmetry acting vertex point between those two numbers. So we're going to take the average, so negative 1 plus 1 divided by 2. That ends up being 0 over 2, which is 0. So here I have something that acts like a vertex point. It's going to be a local minimum or local maximum that's occurring right at x is equal to 0. So I can label that there, and then I know that x is equal to 0 is a key point. So I need to calculate what that key point is going to be. And I take my x value here and I substitute it into my equation. And my equation is going to help me determine whether or not I have a local minimum or a local maximum. So we have y is equal to 2, and then I have 0 minus 5, 0 plus 1, and 0 minus 1. So here I have 2, negative 5, 1, negative 1. So this becomes 2 times negative 5 is negative 10, which then times 1 is still a negative 10, which times negative 1 becomes a positive 10. So I can see here that I have a key point at x is 0, y is 10. So I'm going to plot that point estimated about right there. So I have a key point at x is 0, y is 10. So I can see that it's coming up, and then it's going back down. So I can kind of estimate that. It's not a perfect graph, but that's okay. And then this would continue down here. So that's at least a part of our polynomial function there. Then from here, I need to focus on my second pair of points. So here I have 1 and 5. So I'm going to focus on 1 and 5 there. So I'm going to take 1 plus 5 divided by 2. So that's 6 divided by 2, which is 3. So I have a key point at x is equal to 3, and I'm going to add that to my picture as well. So here at 3, I'm going to draw what looks like an axis of symmetry, knowing that I'm going to have some sort of key point along that line, acting as a local maximum or a local minimum. So we have y is equal to 2, then I have 3 minus 5, 3 plus 1, 3 minus 1. So I get y is equal to 2, then I get, that's negative 2, 4, and 2. So y is equal to, we get negative 4 times 2. Well, negative 4 times 4 is negative 16, which times 2 is a negative 32. So I have an important point at x is 3, y is a negative 32. So I'm just going to estimate that it's way down here. So my graph comes down and then shoots back up. So here I have x is 3, y is negative 32. So if I look at my graph, I can see that I have 3 x-intercepts labeled in blue. I then also have a maximum point here, a local maximum point at x is 0, y is 10, and a minimum point here at x is 3, y is negative 32. So those are the 5 points you need labeled. You need to be able to find your intercepts as well as any minimum or maximum local points that are between those intercepts.